Hello and welcome to the AI Engineering Podcast, your guide to the fast-moving world of building scalable and maintainable AI systems. Seamless data integration into AI applications often falls short, leading many to adopt RAG methods, which come with high costs, complexity, and limited scalability. Cogni offers a better solution with its open-source semantic memory engine that automates data ingestion and storage, creating dynamic knowledge graphs from your data. Cogni enables AI agents to understand the meaning of your data, resulting in accurate responses at a lower cost. Take full control of your data in LLM apps without unnecessary overhead. Visit aiengineeringpodcast.com/cogni, that's COGNEE, today to learn more and elevate your AI apps and agents. Your host is Tobias Macy, and today I'm interviewing Julian LaNeve about how to avoid putting the cart before the horse with AI applications. And when do you move from simple LLM apps to agentic AI, and how do you get there? So, Julian, for anybody who's not familiar, can you start by introducing yourself?
Yeah, of course. Thanks for having me, Tobias. Like you mentioned, my name's Julian. I'm the CTO at a company called Astronomer. We work with the open source tool Apache Airflow, which is, the most popular data orchestration tool there is. We've built a business over the last 6 or 7 years managing and running Apache Airflow for our customers, but have since extended into data observability, cataloging, quality, plus machine learning operations. We get to partner with data engineers around the world, helping them take anything from simple ETL workflows to more complex LLM workflows and deploy them in production where they run very reliably.
And do you remember how you first got started working in data and AI?
Yeah, it's always been something that's interesting to me. I think it was pretty clear to me from a younger age that data is here to stay and you can go do lots of interesting things from it. I, as probably many people who are listening, got started with very simple data science and modeling, and then eventually learned more about ML and found it exciting because you can defer to the kind of computer, if you will, on how to go structure and find patterns in data. And of course now everything's about AI and LLM, so I'm excited to talk about that as well.
In the context of AI applications, there are so-called simple applications, which, given the nature of the technology involved, I would say is anything but simple, but comparatively. And then there is this broader category of applications that is termed agentic AI. And I'm wondering if you can just start by laying the groundwork for the conversation as far as what is the juxtaposition there of agentic AI, what does that involve in terms of technologies, competencies, as opposed to simpler LLMs and some of those operational characteristics that need to be accounted for.
Yeah, of course. I'm actually going to lean on Anthropic's definition here because they wrote a great article a couple weeks ago called "Building Effective AI Agents." I'm sure most of the listeners here have seen it, and if not, I definitely recommend reading it. So the way they draw the distinction is that these LLM workflows are these systems where LLMs and tools are orchestrated through very predefined code paths. So there's some level of determinism where you can anticipate what's going to happen, like the general control flow of the application. Agents, on the other hand, are systems where the LLM itself decides the full control flow. They kind of direct their own processes, tool usage, and you kind of defer everything to the LLM. But you make a good point around these things are anything but simple. It's interesting because it does feel pretty simple to work with LLMs, and that's because these frontier model providers have done a great job of making them very simple to work with, right? They take on all of the complexity of actually building, training, and hosting and scaling these models to the point where to consume them, you can go to ChatGPT and ask a simple question or make a very simple API request. So I'd love to, get into that more too.
As we move from this idea of straightforward LLM applications where we're just doing a single call and getting a single response back, and then moving to these more orchestrated workflows, whether they're deterministic of just a very straightforward procedural calls of take the output from this one, feed it into the next one, or if it's more of the self-directed, more fully agentic and automated workflows that are starting to grow. What are some of the technical challenges that are often underestimated or misunderstood or just completely unknown as teams start to try to go straight from I have an engineering team to I'm going to build an agentic AI application?
Yeah, I mean, so the way I break it down in my mind is like there's two types of AI applications, and there's two levels of control that you need to pick from. There are obviously synchronous applications, so things like ChatGPT, these chatbots, something like Cursor, where you're interacting with it live and you expect a live response, right? You're going to sit there and wait until the LLM or this, agentic system gives you a response. And then there's also like these asynchronous or like more batch oriented workflows where you might go trigger some set of actions, but you are not actively sitting there waiting for a response, or like you want something to run on some cadence. I mean, the most popular example of this today is like ChatGPT's deep research, where you can ask it a question, it'll kick off kind of a full workflow or set of agents, and you can sit there and wait for a response, but it oftentimes takes a couple minutes, up to 15, 20 minutes. The world that I live in is primarily in these more like batch oriented asynchronous workflows. Again, I mentioned I work with a lot of data engineers. They live in the world of, more traditional like data engineering workflows, data pipelines. And then there's, the two levels of control that we talked about, the LLM workflows where you have some like predefined code path that's going to get run and you're using an LLM as part of that, versus an agent where you're deferring kind of full control to the LLM system. I think where I've seen people have the most success so far is with LLM workflows. And the reason for that is like you end up not introducing unneeded complexity. I mean, like the analogy that my head goes to is like building an agentic system is like trying to build a microservices architecture, right? Like that complexity is definitely needed at times. I mean, we have a bunch of microservices here at Astronomer, but you're not going to go build microservices like before you've built your first API. And that's what we see teams doing. I work with a lot of teams who have kind of stood up these like full AI centers of excellences. They go straight for, let's try to automate an entire human's job with AI. Let's go automate all of support with AI. And, you end up putting the cart before the horse, right, as you mentioned at the beginning. And it's exciting, don't get me wrong. Like I definitely believe in kind of the promise that agents bring. I think in the long term people will realize a ton of value from them, and like we're building our own agents here at Astronomer. But when you go straight for agents, what happens is like you miss all of this low hanging fruit, these like very simple things that you can do. I mean, I'll give a couple examples that we've built out here at Astronomer, and I can talk about more of what we've seen kind of our customers and communities do. We're working on a new major release of Airflow right now, Airflow 3.0, which is something that myself and the entire company and community is super excited about. I think it'll be the biggest release in Airflow's 10-year history. But as I'm sure you can imagine, there's a lot of activity going on in the open source community right now, right? It's a big open source project. There's multiple companies, a ton of individual contributors contributing to it. And like even things as simple as keeping up with the development is tricky. I used to log into GitHub every day, literally look through the commit log because I get questions all the time about what's coming in Airflow 3, like how is it progressing? That's the type of thing that an LLM workflow is great at, right? It's effectively a simple data pipeline at the end of the day. I ended up writing something in like 20, 30 minutes that pulls the latest commits from the previous day from GitHub's API, feeds it into an LLM to do both filtering and summarization. It's like I don't care as much about bug fixes or like kind of the normal activity, but I do care about like big new features. And then it sends me an email and a Slack message every day. To the earlier point about like complexity in these things, like LLMs themselves are quite complex. Like I'm not going to pretend to understand them to the level of researchers at OpenAI, but they're super easy to use, right? The fact that I can go build that LLM workflow in 20, 30 minutes is because the complexity comes from the orchestration tool, right? Airflow in this case, it's doing a lot of heavy lifting. And the LLM, right? All I have to do is make a simple API call. And we've seen customers, transform their entire business with these LLM workflows where, that one use case in and of itself takes 20, 30 minutes to build, saves me 10 minutes a day. But if I go do that a dozen times every week, that adds up very, very quickly. And you can go scale that across the entire organization. So, for example, we work with a big fintech customer. They're growing very rapidly, scaling their go-to-market organization very quickly. And one of the things that they did was they had an engineer sit down with a sales rep for a full day. That engineer looked at everything that sales rep was doing, right? Taking in all these inbound leads and calls, reaching out to a list of prospects, getting on customer calls, pitching the product. And that engineer came away with a dozen ideas immediately for things that could be automated, not by building a full multi-agent system that's going to try to do everything that sales rep is doing, but taking these very specific things and doing them very well. So, again, I've seen companies approach it both ways, of let's go build out a bunch of agents and try to automate as much as possible immediately. And let's go build out kind of these simpler LLM workflows that might not be as exciting as multi-agent systems, but are very pragmatic and make a real difference, especially when you add them up.
I think that microservices analogy is a great one to build around in this context because in microservices, when it first came to the general awareness of the engineering community, everybody said, oh, great, microservices are the way that you build software, no matter what. And then everybody who had worked with them a lot really said, actually, it's more of an organizational efficiency than a technical efficiency, and it can actually cause a lot more problems. And so I think that's a good parallel to this idea of agentic versus single LLM use cases, where the purpose of microservices isn't necessarily to make your architecture great and make everything more maintainable. It's more to manage the communication boundaries of the organization, of the engineering teams. And they also require a lot more orchestration and overhead of making sure that changes are compatible as you release them, making sure that the APIs and the contracts that you're building around are stable. And I think that that holds true in this agentic context. And also, people who do eventually build toward microservices are usually starting from a monolith where they have one application that does all of the things and then they'll peel pieces off into smaller portions. And I'm wondering what you see as that as a parallel in the engineering and design space of these LLM applications as you migrate to these agentic workflows and just building up the operational capacity and knowledge of running those single monolithic workloads, even if it's just a very small use case, and then being able to peel pieces of that into more of this agentic architecture.
Yeah, I mean, I definitely do love the kind of microservices versus single API analogy. I think it makes it pretty clear what the challenges are. But I also like it because if you think through the history, right, of microservices, there's a lot of excitement about them at the beginning, to the point where you would use microservices for things that probably didn't need to be microservices, but it's a fun technical problem, and people love solving fun technical problems. We're starting to see this wave now of people really starting to question whether microservices are necessary, right? Because it does introduce a lot of operational complexity. And I anticipate we'll see the same thing with these agent systems too, where they're very fun technical problems. It's very fun technology to work with. But usually you don't want to take on that complexity unless it's absolutely necessary. And I think there are also lots of parallels between these microservice architectures and these multi-agent architectures, right? Observability, API contracts, change management, monitoring. So I think there's definitely plenty there. And again, microservices will always have a place in technology, right? Like there are a lot of cases where that complexity is warranted and it is needed. In the same way that I anticipate like agents will always be around, but that doesn't mean you should ignore the possibility of like simplifying things as much as possible. Because the other benefit to that too is like I've seen teams that will go try to build out these multi-agent systems, and if it doesn't work as well as anticipated, which happens like very, very often, I'd even say in the majority of cases, because there's so much promise and hype around agents. The businesses is like they're not going to want to invest more in agents versus if you take the other approach of like build as many LLM workflows as possible, like go after the low-hanging fruit, build these kind of simple, more pragmatic things. That's what's going to get the business excited because you'll go introduce efficiencies across the entire business. You'll be able to build products and like do certain things that you wouldn't be able to otherwise. And then the business will be excited and you can go justify investment in kind of these full agent architectures after you've built like some level of operational capabilities around these LLMs, after you've built like intuition for what they're good and not good at. So that's the approach that I mean we've started to take at Astronomer. That's the approach that has gotten me most excited from how customers have been talking about things. And that's generally the approach that I recommend now.
In terms of the capabilities, the underlying technical systems that are necessary, whether it's for these monolithic versus microservices, to extend the analogy, use cases of the single LLM back and forth conversation to these agentic capabilities, what are the underlying requirements around data infrastructure, operational infrastructure, orchestration, and observability capabilities that should be in place before you start to make that migration to the more complicated but potentially more fruitful microservices or agentic use case?
Yeah, so I mean, I'm certainly a little bit biased here because again, I work with Airflow and data engineers quite a bit, but I'll try to put my bias aside for a second. I think like the ability to, I mean, build, test, and deploy LLMs in the same way you would build, test, deploy, and obviously kind of monitor and observe traditional APIs follows very closely. So on the build side, there are a bunch of kind of these open source tools that have gotten very good around building abstractions on top of LLMs to make it easy to, build around these LLMs, switch out models when you need to, define tools. The one that I've seen and have enjoyed the most so far is the Pydantic AI library. I've played around with LangChain, Llama Index, OpenAI's libraries, and a bunch of others. I think like the Pydantic AI approach feels very practical in the sense that the Pydantic team itself obviously has been working with Python for many years now, and they know what good looks like and how to build very stable APIs. And you can definitely feel that when you start to use Pydantic AI. It's definitely it's the right balance between like giving you abstractions that make it easy to work with LLMs and define tools and think about things like observability, but it also doesn't feel like it gets in your way. Like when we first started using LangChain as an example, it was great when your use case fit very well into kind of the LangChain way of doing things. But if it didn't, and we ran into this all the time, like you were better off just like importing the OpenAI library and like writing the code yourself. So that's on the build side. Again, I think it is important to use one of these abstractions because new models come out every month, right? And like you want to be able to adopt and test those models without having to go like make major refactors or like switch from the OpenAI client library to the like Anthropic or Gemini one. Testing these models is oftentimes, I mean, pretty tricky. Like there's no science to it right now. In my view, it feels a lot more like art. When you're able to break things down into these like very specific use cases, these LLM workflows, usually like you can just do a bunch of manual testing and build some intuition for like, does this work well or does this not? Especially as you start to build more and more of them, like you can get that sense a lot quicker. For example, like with that GitHub changelog summarization example I was talking about. Like, I didn't go and build like a very robust evaluation suite. Like, LLMs generally are good at summarizing things in my experience. I played around with it a ton. I like tweaked the system prompt until I was generally happy with the output and then deployed it. And like, as I get results back, it sends me an email every day. Sometimes I'll go back and change things. Like, if it's giving me a commit that I actually think is like not all that interesting, like I'll just go update the system prompt and kind of tune it over time. Outside of like this kind of artistic style of evaluation, I think it's tricky because it becomes a rigorous academic problem very quickly. And again, it's a fun academic problem for sure, but that can also get in the way of like you actually building and deploying these things. LLMs as a judge feel like a nice way of doing evals where like there may be some slight variation in how responses are worded, but like as long as those generally mean the same thing, LLMs can be good at determining that for you. There are things like the kind of SWE benchmark that take a nice approach of like you generate some code and actually run it through unit tests to validate whether that code is correct or not. I think that's great if you have a use case where you can test it very well, but in my experience, oftentimes that's not the case. So we talked about builds, we talked about tests. Deploying, again, I think depends on whether you're like one of these synchronous workloads or asynchronous workloads. I think for these asynchronous workloads, like the traditional data engineering tools actually work quite well because it gives you all of the kind of functionality that you need out of the box to kind of build, manage, and monitor these, essentially data pipelines at the end of the day. Things like scheduling, triggering on events, dependency management, retries, like a UI on top of these things. Like, that's what Airflow gives you. And that's why we've seen a ton of success so far with just like kind of fitting these LLM workflows into a more traditional orchestration tool. And then on kind of the monitoring side, I'm a big fan of, looking at it two ways. One is like the same way you'd want to monitor any application, like you need metrics around like, is this thing up? Is it low enough latency? Can I understand how many tokens I'm processing? Because like there's very real cost associated with it. But for actual like metrics of how the LLM is performing, I like to go to product metrics instead of like the more academic benchmarks. So like the most simple example is like we've deployed something called Ask Astro. It's like a simple kind of Q&A application over all of our Airflow and astronomer knowledge. And like I know it's doing well if it's getting a lot of usage and people are like rating those questions as correct. And like that to me is a lot more important than, this like internal benchmark of 500 questions that we've generated, because like we introduce certain biases like when we go create that data set versus like how it's actually used in the real world. I think once you do that enough times, like it actually becomes super quick and easy to the point where like we've seen customers deploy new LLM workflows like multiple times a week because again, like you come up with this very specific problem that you can solve well. You couple it with like the right orchestration technology in this case to make it super easy to build and deploy these things. And then you just keep going. And I think once you do that enough times, like that's when it feels like you're ready to start thinking about agents, because regardless of like if that agent or multi-agent system performs well or not, like you're already delivering very real value to the business, and like that is a win in and of itself. That also gives you the flexibility to go kind of do the more interesting things over time.
Talking through the orchestration piece, I think it's also interesting to talk through some of the architectural manifestations of what an agentic workflow would look like, where typically you hear the idea agentic AI, you think, oh, this is all one application. It has one kind of monolithic runtime where maybe you're using something like LangGraph or but as you said, it can be an asynchronous workflow where maybe it's not all one chain of calls that exists within one process running on a server somewhere. Maybe it is one AI call that's executed by one of our standard data orchestration platforms, whether it's Astronomer, Dagster, Prefect, etc. and then that generates an output that gets fed into the next stage of the DAG. Maybe there's some standard procedural code that gets run on it that gets fed to another AI call. I think that you could technically consider that as agentic AI as well, because it is multiple LLMs operating collaboratively in a system with some means of orchestration, not necessarily having that orchestration all be in process in one executable. And I'm wondering what you're seeing as some of the ways that people are starting to explore that architectural principle of agentic AI and agentic applications that maybe span beyond the bound of one single Python script or executable that gets deployed to a server somewhere.
Yeah, I think like the best example I've seen so far is these code generation agents. Things like Cursor, Windsurf, GitHub Copilot now is turning more agentic, where there's a lot of ambiguity in what you ask it to do, right? Like it's not a very well defined problem where you can anticipate what needs to happen before it actually happens. And like a lot of these LLMs today are very good at generating code. And so it also works nicely from that regard. Like if you look at maybe Claude Code is a good example where it is, the kind of Claude set of models, but then you couple it with like 20 to 25 tools that are like, lists all the files in a directory and read a single file and perform a search and update a file or do a search and replace. Those things work very well if you have a human in the loop, I would say is the big caveat, where you need like some level of oversight into what's going on. Because I mean, maybe the right way to look at the math is like, let's say for every operation the agent does, it has like a 95% chance of getting it right, which is very, very optimistic, but I think can also help illustrate this point. Like, let's say your agent system is on average going to do 10 operations. If you take that 95% to the 10th power, that's like 60% or so, if my math serves correct. And like, 10 feels kind of low for like when I use Claude Code as an example, right? Like it's doing, 20, 30 things at a time. And it's pretty impressive, like what it can do, but it compounds very quickly, which is why I think having that human in the loop is important. The number of times like Cursor, for example, has been able to one shot things for me is very low. But I also don't mind because it's super easy to reprompt it or, give it some addendum to go like, fix something. I think where you start to get into trouble is when you do have these multi-agent systems with no human oversight, which generally like aligns to these more asynchronous workflows where like you don't have a human sitting there like actively looking at what it's doing, because then like that 95% compounds and it compounds, and like the chances that the kind of end result is what you'd expect or what is useful, like it just goes down the more complex these systems get. So generally like what I've seen work well is if you have these like very synchronous workflows, like code generation again is a great example, because like if you're using Cursor or using Claude Code or Windsurf, like there's a human sitting there looking at the output and continuing to refine it. That's when these agents work great, because the accuracy almost doesn't matter quite as much, because you can reprompt it to get the accuracy up to where you expect it to be, and like you're still saving time at the end of the day, right? Because it can just write code so much quicker than a human can. But when you start to deploy these things asynchronously, it gets very tricky, because the full thing is kind of like a black box, right? You give it some input, and then like at some later point in time it gives you some output. You can go back and like trace what happened, but you can't take corrective measures, which is again I think like kind of why these LLM workflows are so interesting, because they are less of these like agentic systems where that 95% compounds. They're these like more very specific use cases, and you can trust them to run asynchronously.
Digging more into that compounding error rates and the compounding of the confidence windows decreasing as you layer more and more of these AI calls, what are some of the observability aspects that need to be in place to be able to mitigate some of that, where maybe you have some insight into what is the confidence interval for a given output, and then maybe having some sort of circuit breaker where as soon as that confidence interval drops below a certain threshold, you stop or pause the workflow and then maybe page somebody who is going to be that human in the loop to intervene or take over the workflow from the agent because it has gone too far off the rails. And in that context as well, some of the observability around the security and risk appetite, where maybe you need to incorporate guardrails in combination with that confidence threshold.
Yeah, that's a good question. I mean, I think first off, like, if anyone can measure the accuracy of these agents as they're performing, like, that is a many billion-dollar problem. So I'd love to talk to you if you have it figured out. I think, like, there's the general observability of, like, can I understand what this agent is doing? The Pydantic AI approach, which I think is pretty clever, is like you just emit every LLM call and tool call as like an open telemetry span and trace. And like that's nice because you can go plug it into like your more traditional observability tools and understand like exactly what's going on. That becomes super helpful if like you get some output and like want to understand how it arrived at that answer, as an example. It doesn't really help kind of as much with the accuracy problem. Like it helps you understand why accuracy might not be great. You can test like the agent's ability to reason through certain things. Like this is where benchmarks might actually be interesting and helpful, where instead of benchmarking like the kind of full agent system at once, where like given some input, like does it come up with some output, it's helpful to try to break down the problem into very specific things. So like with the coding agent as an example, like maybe you want to benchmark its ability to turn the user's query into like a search across the code base, right? And if you like that's a much easier thing to benchmark than like given some input prompts, like can it generate the right code? Because that also helps you like build out the benchmark over time, where if, for example, like you get bad user feedback around like a certain type of problem, you can couple that with like the traditional observability methods to say, okay, where did it go wrong? And then you can go build benchmarks for those things in particular and start to tune the agent system over time. Ramp also had a pretty clever talk a couple weeks ago that I think they posted on their YouTube or maybe as part of some podcast, where like one easy but expensive thing to do if you care a lot about accuracy is just like let the agent run many times in parallel and then like use an LLM as a judge at the end to try to catch certain patterns or like draw certain conclusions. Like for example, this is maybe a silly example, like if I have this asynchronous workflow that's like doing some, let's just take like deep research as an example. I'm going to give it some prompt. It's going to go off for a half hour and like come up with some answer. Like you can have that agent run once and you'll probably get a good answer, right? Like OpenAI has proved that this is possible. But if it's something super critical and like you care about not hallucinating and, you know, it being as accurate as possible and you're willing to spend, you can go run that agent 100 times, right? And come up with 100 different reports and then use an LLM at the end to like draw its own conclusions around like, hey, if you know 80 of the reports like all mention this one thing, then like probably that thing is true. It's like kind of similar to what these frontier model providers are doing with chain of thought, right? Like you just give the LLM more tokens to think.
For organizations that are evaluating and investing in these AI capabilities, whether it is a single internal chatbot or people who are using it for their development inner loop, or evaluating whether to deploy some agentic workflow for business process automation, whatever it might be, what are some of the key heuristics and questions that they should be asking as they determine which style of AI application they should be investing in or evolving towards, and what are some of the key milestones that they should be measuring against in that process of implementation and adoption to decide, do I just go with a single LLM? Do I incorporate that into a broader application, or do I build some sophisticated, orchestrated, agentic AI application?
Yeah, I think the two most important things that I've seen are the actual experience of how you work with it, because that can make or break things. And like personally, I would love to see a lot fewer chatbots out there. Like that seems to be the kind of de facto standard of what people build. And I think we can be a lot more clever than that. Like the UX matters a ton because that's what's going to drive engagement outside of like the accuracy of the thing. And also like where your unique differentiation for this is going to come from, right? Like for most organizations that aren't like Cursor, where your differentiation comes from like how accurate the system is, oftentimes you're just going to defer to these frontier model providers, right? Like given the velocity of how quickly new models are coming out, I think it makes a lot less sense to try to fine tune things unless you have like very specific use cases or like some unknown kind of pattern or set of data that you're working with. This is why, I think I've seen so many data engineers build successful examples because like oftentimes that differentiation comes not from the models but from like your ability to supply data to those models, and then like the differentiation comes from the data, and nobody knows the data better than the data engineer, right? And data engineers are also very intrinsically curious. Like they're playing around with LLMs, they're thinking about use cases. um, so I think really thinking about why it makes sense for like you as an organization to do this is super important, because like vendors will come out with AI driven tools. Like if you don't have some sort of like unique data or perspective on the problem, it's a lot cheaper and easier to go use a solution that kind of someone else with that differentiation is building. But if you do have the data, it does become super interesting because it means that what you can do looks very different than what anyone else can do. And this is where like we're starting to see a lot of organizations make the jump from kind of traditional like ETL processes, like go build dashboards. It used to be the case that before you even thought about like AI or NLP stuff, you'd have to go like build up an ML team to do some like kind of numerical ML models. And like that's very expensive. Now you can go straight to AI. I think like for data teams across the world, there's like this general notion that they could be doing more with the data, right? Like you make this big investment in something like Snowflake or Databricks, or pick your data warehouse or data lakehouse nowadays. You go get all this data nicely formatted, it's clean, it's in the data warehouse, and then the game becomes like, what can you go build on top of that data? It used to be the case that it was all like reporting dashboards. We're now starting to see a lot of people do like data powered applications where like you're feeding the data directly back into an application, and like that becomes a production system. Now it's like super easy to just throw that data to an LLM and get a ton of value out of it. You can think of a ton of clever use cases without having to like build a 70 billion parameter like LLM yourself. So the fact that like these frontier model providers are doing all of that work for you, I think makes it super interesting to think about it from like a unique differentiation perspective, right? Where you have access to some unique data, you want to go get more value out of that. There's a bunch of these LLM use cases you can think of.
Another interesting element of the agentic workflow and the implementation that we've already touched on several times is the idea of orchestration, where the orchestration typically takes the form of some DAG or directed acyclic graph. And I'm wondering how you see the organizational awareness and understanding of the nature of DAGs manifest in terms of their ability to effectively implement these agents, and maybe some of the ways that we need to explicitly call out the differences between a DAG and Boolean control flow for these types of workflows, and then also the potential for the AI to dynamically manipulate or generate the graph as part of that execution.
Yeah, I mean, that's probably a good way of thinking about the difference between like an LLM workflow and a full kind of agent or agentic system is like, how predictable is that DAG? And is it a DAG or is it a directed cyclic graph, right? Like, can it go back and repeat certain things? I think if it can be a DAG, that's better because they're more reliable, they're easier to observe and understand, and you don't run into as many issues around like accuracy, right? Because it's a lot more
Or
predictable.
the halting problem.
Yeah, exactly. And you like even if you're kind of sticking with the DAG shape, there's a lot of clever things you can do, right? Like branching is something that's been around in these orchestration systems for a while. It used to be the case that like you would have to deterministically come up with which branch to go run, but like we've seen a lot of people use LLMs to determine which branch to run. Like maybe a classic example is like support ticket routing, right? A new ticket comes in, if you wanted, like in a pre-LLM world, if you wanted to try to automatically route that to the right team, like you were doing topic modeling and like other kind of NLP things, and like those are great, but they're like not as easy to do as like making an API call to an LLM. Now you can just like craft a clever system prompt, give it to an LLM with the ticket content, and let it decide like, is this a P0? Does this go to this team? And like that's still a DAG structure, but a very useful business problem. So I like that way of looking at things.
One of the other things that you mentioned as far as the typical evolution of technical maturity for teams who are going from building up their data suite and coalescing the data to then they have to build out their data science and machine learning team to be able to build their custom models and evaluate them and test them and do a bunch of A/B testing as they deploy them and have the typical ML ops workflow of build, train, deploy, evaluate, repeat. Most people are skipping that stage of building out the ML capability internally. And as you said, jumping straight to AI because the interfaces are simpler to get started with. But I think that it also introduces a certain amount of potential for risk in that they don't have that existing institutional knowledge of the probabilistic nature of these systems and how to actually manage and deploy and scale them effectively. And also, in many cases, you might not even have a data team because the LLMs are so easy to get started with. You might just be a single engineer or a team of web developers who are tasked with here, add AI to it. And so they say, okay, well, I'll just call OpenAI or I'll call Anthropic, and not necessarily understanding the utility of having that data grounding and the operational characteristics of data workflows. And I'm wondering what you're seeing as some of the ramifications of that leapfrogging, as it were, straight to these AI capabilities.
I mean, to put it bluntly, like that's why a lot of these AI projects fail, right? Because you get excited about the technology, you don't have the intuition for what these models are good or not good at. You don't understand how to work with them and deploy them to the level that's necessary to actually rely on them in a production setting. So you try to do it, you release it, and like you get, bad feedback about it, and like you end up shutting it down. I think that's the case for majority of projects today. Um, and you can draw like parallels with data science and ML teams, right? Like when you go start a new data science team or ML team, like if you haven't had one before, you don't go straight to the deep end and like try to train a very complex model. Like you start with the simple kind of low hanging fruit things and you build that like ML ops practice over time. Right? It always looks a little different from organization to organization because again, you build it over time. Like you come up with what works for your organization, which might be very different than what works for a different organization. I think like if you draw parallels to the LLM space, you can kind of follow that same model of like start with the simplest example possible, even if it's like maybe not as exciting to you. Like again, I keep going back to this like GitHub changelog example. Incredibly simple, but also valuable enough that it's worth doing. And like you don't want to go build these like full agent systems unless you trust that you know how to operate them. And it's tough to know how to operate them if you can't operate like these simpler LLM workflows. I mean, maybe if we like go back to the API versus like microservice analogy for a second, like there's a lot of things that can go wrong within an API, right? Even if you just have one. And if you go build and release an API and you're responsible for maintaining it, like you build some institutional knowledge around what can go wrong with that thing, right? Like you end up with a run book that describes, hey, here are the common things that can go wrong. Here's how you fix them. You build up this kind of institutional knowledge and intuition for how to operate that. And then when you go introduce multiple APIs and get to this more microservices architecture, like you still have the problems of what can go wrong within an API, but at that point, like you're very good at dealing with those, right? Like you know how to build for those from the get-go, you know how to resolve them much quicker if it goes wrong. And what you're doing is instead introducing more complexity on like how these things interact with each other, and that becomes the problem that you then have to solve. But if I was to go try to build a microservices architecture today, and I was not good at writing APIs, and I was trying to solve this like distributed problem, like there's going to be fires all over the place, and like probably I will be fired. Like if you draw the same analogy with like these LLM workflows versus like multi-agent systems, if you try to go and build a multi-agent system, there's a lot that can go wrong, both like within how you interact with a single LLM and how those LLMs interact with each other. Like you want to get good at solving one problem before you move on to the next.
Another piece of the technical stack that is typically necessary as you move to these more agentic workflows is a more comprehensive and sophisticated data layer for the agent to be able to maintain state, particularly as it hands off between these different LLM calls, where that typically involves more than just a vector database. For like a RAG use case, you need something that maybe has more of a graph nature to it for being able to understand the relation between these different data elements, or some sort of memory system for being able to balance between short-term context and long-term history, especially as the agent evolves in capabilities and use cases and runs for a greater period of time and needs to be able to recall some of those more historical pieces of data to feed back into more recent requests. And I'm wondering how that also impacts the speed of execution and the ability for businesses and teams to be able to actually build and sustain these more complicated operational infrastructures.
Yeah, it's a good question. So, I mean, the way I think about it is like there's probably three ways of having these LLMs interact with like some sort of data, whether that's like memory, context, kind of, documents that live in vector databases. So the first is like the more traditional like RAG architecture, where you're going to go build a vector database. You can kind of anticipate what the LLM needs to know ahead of time. And you can do like, semantic search, hybrid search to go retrieve documents. And like at that point, you're trying to solve this like context window problem of, hey, I have more documents than can fit in my context window, so I need to store them someplace else and like let the LLM retrieve from those things. I think like there's probably going to be a lot of innovation there. It also becomes super clear like who's worked on search problems and who hasn't, because I think like fundamentally that's just a search problem at the end of the day, and these search problems have been around for a while. The second like piece of data that the LM has to interact with is like the context of like what it's trying to do right now. So like you're going to go kick off this multi-agent system. In the same way, like with traditional applications, you need to do like cross API monitoring and state sharing. Like you have some of the same problems with these multi-agent systems. I haven't seen candidly like too many examples of that, because to get to that point, like you have to have successfully deployed agent systems in production before you move to like these multi-agent systems. I think what happens a lot of times is people will go deploy a single agent, you run into some operational problems with it, and like you keep investing more in that problem before you move to these multi-agent systems. But I think like there are some very well-defined patterns of sharing state across applications in kind of the more traditional software engineering world that I anticipate will probably be applied here. And then the third is like this idea of long-term memory, where like you can't anticipate ahead of time what that long-term memory is going to be. You want the agent system to kind of learn on its own over time. Like the simplest example of that is like if you go to ChatGPT and ask it to remember something about you, like you'll get a little toast message that says like, okay, we'll remember that. And then at a later point in time, like you can go into your settings, your profile, and it'll show you like the memory that it has about you. Like I think that's a pretty nice and clever way of doing things where you, in some senses, are letting the LLM decide what goes into long-term memory. ChatGPT seems to do it in real time. I anticipate that you can probably do that like asynchronously. You can have some like data pipeline that runs after the interaction that goes and looks back through kind of the set of messages or like what happened and let the LLM pick out like, oh, this like seems important for me to remember. Let me go store it someplace. I think like how that's stored and how it's retrieved is another question. For things like this like ChatGPT memory concept, you can just like store that in plain text and go retrieve it every time and like put it in the context window. This is like similar to cursor rules, maybe is another good example where you can supply like a bunch of markdown files and rules and give it some specificity around like this rule applies if you're operating on a Python file. Like that's essentially long-term memory. In this case, it's like the user defining that memory instead of the agent defining that memory. But you can imagine a feedback loop where like the agent starts to define that memory as well. And you can do that as long as like you don't anticipate the memory growing to be too large that it cannot fit in the context window. I think for a lot of these multi-agent systems, probably the memory will grow to be more than can fit in the context window, in which case like you go back to kind of a vector database and search and like context retrieval problem, just with instead of like documents that you can kind of load into the vector database on your own and anticipate the LLM needing, like you let the LLM decide what also makes it into the vector database.
From a tooling and framework perspective, obviously you're very familiar with the Airflow community, the use cases for it, the people who are building with it. What do you see as the opportunities for that orchestration layer to facilitate the development, deployment, and maintenance of these more sophisticated AI-driven agentic workflows?
Yeah, it's a good question. So I think of it probably in two ways. The first is like the agent is the DAG, in which case like Airflow and these orchestration tools fit in quite nicely because Airflow is there for building DAGs, and you'll want to observe, monitor, retry these agentic workflows in the same way you would want to a traditional data engineering pipeline. And that's where like if you go use something like Airflow that's been solving and learning how to solve these problems for the last 10 years, like you're going to start with a level of operational maturity that no one else has. I've also started to see some cases where like you run a full agent as part of a DAG. So like one node in the DAG, one task in the pipeline is running an agent. So like maybe a good example of this is, we have customers that are doing support ticket classification and routing, which I think I talked about a bit earlier. That data pipeline gets kicked off whenever a new Zendesk ticket is logged, right? Like Airflow supports event-driven pipelines. When this new like Zendesk ticket comes in, that triggers an event, which triggers the Airflow pipeline. The first step is like go retrieve information about that Zendesk ticket itself, the customer, the kind of context that customer has, and then feed that to the second task, which is running a full agent. In this case, like you're kind of prefetching or preloading a lot of the context that you know is going to be important for this agent system. The agent's going to go do some work. It's going to call some tools. It like decides its own control flow. Ultimately, it comes out with either like a draft response or like tags or some categorization or like some routing logic. And then like that gets picked up by the third task, which might be writing back to Zendesk. So that's another common pattern that we're seeing where like you run the agent as one step in the pipeline, but like there's always some things that happen before the agent, after the agent, maybe even like in conjunction with the agent that makes it fit into these like very classic orchestration systems. And it ends up being like a very nice better together story, because when you want to go build an agent system or an LLM workflow, the complexity is going to come from two places. The first is like, how do you go actually like chain this business logic together in a way that's reliable, in a way that you can observe and monitor? And like that's a data engineering problem. That's what these orchestration tools exist for. And how do you go like train and get access to an LLM, which all the frontier model providers are doing for you? And that's why it becomes so simple and quick and easy to write these LLM workflows, because the complexity comes from the orchestration tool, which you're going to get out of the box, and the LLM, which you're going to get out of the box from these frontier model providers.
In terms of your experience of working in this space, working with the Airflow community, and exploring this constantly evolving space of LLM applications, agentic applications, what are some of the most interesting or innovative or unexpected ways that you've seen teams build toward those more sophisticated agentic microservice use cases?
I think the simplest answer is the just like the sequencing problem of when you start by building out these simpler workflows, you get intuition for what works well, what doesn't work well, where the LLMs are good today, where they're less reliable. And that's what helps you evolve past LLM workflows into full agent systems. I think the most common conversation I have today is a customer, community member comes to me and they say, hey, I want to go build an agent for support ticket classification. And like the conversation from there goes to, okay, why do you think this is an agent versus like just making an API call to an LLM? And what you oftentimes find is like, it is just an API call to an LLM, right? Like until you can prove that simple API calls, even if you like give the LLM some tools, until you can prove that that doesn't work for your use case, I think going straight to these like multi-agent systems is generally not a great idea. So oftentimes like you should start simple and only introduce the complexity when it's needed. And there are definitely examples of introducing that complexity. The two most common ones that I've seen are, again, these coding agents where like it's very difficult to try to predict what the LLM needs to do ahead of time. So you give it a bunch of tools and a bunch of context and like it kind of figures it out from there. And we're also starting to see more on like the root cause analysis, observability side of things, where like these traditional observability tools are good at trying to identify when there's a problem, but it gets very difficult to reason about like what that problem is, because like the universe of things that can go wrong in an application is just very high. And so you can use an agent there to, again, like you give it the context around like, hey, here are the logs, here's what's gone wrong, here's the code that was running, here's like the ability to go interact with these systems and like run Splunk queries and Chronosphere queries. Like that's another place where it feels justified. But unless you like truly cannot anticipate what the LLM needs to do or what context it needs, like these LLM workflows just become a lot easier to both build, manage, get value from, and understand.
One other piece that is critical and becoming more important in particularly in the current economy, but also as these systems evolve and as they're in such a constant state of flux, is the idea of cost associated with running these applications. And I'm curious, what are some of the gotchas that teams should be aware of as they move from, oh, I've got an LLM that I call periodically and the cost isn't that bad, so I'm going to go ahead and build an agent system. And then you have a multiplicative effect of the number of calls, the size of the context, et cetera, and just some of the ways that that can act as a surprise and also a consideration at the organizational level before even investing in building something of that nature.
Yeah, this is where I think it's actually it becomes very simple. It's, to me, it's all about attribution. If you can clearly say, I am spending X dollars on this use case, then it becomes very easy to say, okay, that's either worth it or that's not worth it. And this is the case for like traditional data engineering activity too. It's not an easy problem to solve. Like I definitely don't want to be reductive, because oftentimes like these systems get very complex. If the agent is like interacting with multiple tools, then not only do you have to factor in the cost of the agent, but also the cost of like the compute that like, of the tools that it's calling. But if you can go clearly attribute spend back to specific pipelines, specific agents, specific use cases, and couple that with the business context of, hey, this use case is worth like, this much to me as a human, or this much to my organization, like it becomes a very simple ROI calculation. And as long as that ROI is positive, like I think it makes sense to keep building these things. And especially like with today's economic climate, I think thinking about ROI is very important. With these multi-agent systems, it becomes difficult to predict ROI. Like you don't know ahead of time how much each agent is going to cost, how much the tool calls are going to cost. You kind of have to like deploy it and like see generally how long it takes, how many tokens it uses. Does it need like more expensive reasoning models, or can it use like simpler, kind of smaller models? But ultimately, at the end of the day, it's like you calculate the ROI per use case. As long as there's positive ROI, like it's generally worth it to use a business. And the way I've seen this play out, especially with our customers, is when you go take these simple ideas that become very high ROI, support ticket classification, like automatic email generation, like that example of the fintech customer where the engineer sat down with the sales rep for the full day. Like when the use cases are simple, it becomes easy to anticipate how much it's going to cost, and it also becomes simple to kind of build and deploy and monitor how much it costs. And when they are quick to deploy, like you don't have any like emotional or kind of sentimental attachment to them. If it's not delivering ROI, like you can just shut it down. I think you can also anticipate that like model costs will come down over time. So I don't think like you should let the ROI calculations get in the way of experimentation and prototyping. It may be the case that like you go build something today, it's too expensive to be worth it. In 6 months, like that's probably not going to be the case, right? With kind of the pace of innovation on the model front. Um, so I'd say keep experimentation high. When you're ready to deploy something, do like a quick kind of back of the napkin ROI calculation. Like, how much is this going to cost me if I run it every day or every hour? And like, is that worth it to me or to my business?
Also in the engineering too, because of the fact that a lot of these models, as they continue to evolve, you're going to need to be able to swap them. The costs for the different providers is constantly fluctuating. You want to make sure that you build your system in a way that it's not hard coded to a specific API call or a specific model to give you that flexibility and optimizing for speed, accuracy, and cost, and being able to swap between those different implementations of the models, because at this point, the models themselves are becoming a commodity.
Exactly, yeah. And that's why like these tools like Pydantic AI or LangChain or Crew AI, like these abstractions on top of the model providers become so helpful, because the models are a commodity, right? Like you can swap one out with another one tomorrow and not have to really change your code. But that also, again, calls into question, like, if the models are a commodity and everyone has access to the same models, like, how is what you do going to be different than what someone else does? And that's where I get excited. I mean, working at Astronomer is an example, because, like, we work with data engineers who build this very unique and robust set of data that can be fed into these models to build that differentiation.
And for people who are evaluating these use cases, they're excited about all the capabilities that LLMs offer. They really just want to go ahead and start building. What are some of the heuristics that point to AI just being the wrong choice, and just stick with your standard software development practices?
I think if you can do it without using AI, like that's always generally a better thing, because that means you can trust it. It's going to be more deterministic. But also, just because you can do it with AI, like, doesn't mean it's always worth doing it without AI. Like, support ticket classification is maybe a great example here, where yes, like there are very traditional ways of doing support ticket classification. You can do topic modeling, you can do classification. Like, there's a lot of traditional ways of doing that. But like, if you don't have expertise in like NLP and topic modeling, or you do, but it's going to take you a while to go kind of build and deploy a model there, it can be simpler and slightly more expensive from like a pure how much am I spending on this model perspective. But if it means you can go get something out there today instead of 3 months from now, like that can absolutely be worth it. So I'd say, like, take a very experimental approach. Like, think of problems that are unique to your business that you want to solve with or without AI, and just like ask yourself the question, do LLMs make this easier for me to solve? And if I solve this, is it, worth it?
For people who are trying to navigate the current ecosystem, figuring out how best to maintain their relevance as the as engineering continues to change and evolve, and also help to improve the abilities of their organization, what are some of the core pieces of advice that you look to and give to your team to understand what are the things that I need to know about how to build with AI right now?
Yeah, I think, I mean, my general expectation is that today, and certainly more so in the future, the expectation is that, like, everyone should be working with LLMs, right? Like, these frontier model providers, they're building great models. They're much cheaper than if you were to build it in-house. In some senses, they're like subsidizing the cost of intelligence. And like, if you're not taking advantage of that, I think you're going to fall behind pretty quick. And that comes both in the form of like, how do you use AI tools in your kind of day-to-day basis, whether it's like using something like Cursor for writing code, or using something like ChatGPT to generate marketing copy. Like, regardless of who you are, there are tools available to you today that make your life a lot easier and make you a lot quicker and more productive. And for software engineers and data engineers specifically, like, there's a world of opportunity out there if you get it right. If you take this kind of simpler approach to building LLM agents, like, the number one thing that happens when I talk to a CTO or CIO or head of data today is they'll say they've tried to build LLM agents, like these multi-agent systems, but that it fails. And when it fails, like, it's tough to justify more spend on agents and like more investment in that area. So I think if you can build like these very real pragmatic use cases that drive value, like that is an incredibly unique skill set today, and help solve this pretty big disconnect between like the promise of agents and the promise of AI with like how it's actually playing out in an enterprise today. There is this very big disconnect. And the way to bridge that is not go straight off the deep end and like try to build the super complex system as quickly as possible. It's like start in the shallow end, go build things that work very well, and like work your way to the deep end.
All right. Are there any other aspects of this overall space of building AI applications, the path from simple single LLMs to agentic applications and the engineering and operational systems involved that we didn't discuss yet that you'd like to cover before we close out the show?
I think I'll just close with I'm super excited about this technology. We're already starting to see the effects today. I very much believe in kind of the promise that agents come with. I think it's going to be game changing for a lot of people, both because it'll make people's jobs easier and because it'll let you build things that otherwise would be, near impossible. But don't let that excitement get in the way of the value that you can go deliver today, right? If you can start simple, build intuition for these things, build institutional knowledge for what it looks like to build and deploy with LLMs, that's going to position you very, very well for the future. I think there's this general sentiment that if you're not building agents today, you're behind. I think that's very much not the case. In fact, if all you're doing is building agents, you're missing out on a world of opportunity to just go use LLMs in a very simple manner. So I'm super excited. I think it puts data engineers, software engineers, machine learning engineers in a really great position to go change how the entire business is run. And that is what every CEO in the world cares about and is thinking about today.
All right. Well, for anybody who wants to get in touch with you and follow along with the work that you and your team are doing, I'll have you add your preferred contact information to the show notes. And as the final question, I'd like to get your perspective on what you see as being the biggest gaps in the tooling technology or human training that's available for AI systems today.
I think deployment methods is probably the big one. If you go look at LangChain's tutorials, Pydantic AI's tutorials, Crew AI's tutorials, they'll tell you to spin up a Jupyter notebook or some local Python script, and that's great for experimentation. But then what happens when you actually want to deploy it? That to me is not necessarily an open question, but unless you know how to build and deploy more traditional applications, there's a big gap there.
All right. Well, thank you very much for taking the time today to join me and share your experience and insights on the overall space of building these agentic applications and the path to get there without just jumping straight to the finish line and the risks involved. So I appreciate the time and energy that you're putting into that, and I hope you enjoy the rest of your day.
Of course. Thanks for having me, Tobias.
Thank you for listening. Don't forget to check out our other shows. The Data Engineering Podcast covers the latest on modern data management, and Podcast.init covers the Python language, its community, and the innovative ways it is being used. Visit the site to subscribe to the show, sign up for the mailing list, and read the show notes. And if you've learned something or tried out a project from the show, then tell us about it. Email hosts at aiengineeringpodcast.com with your story.